Everyone, we are graphing parametric equations and eliminating the parameter. So a little bit of review over parametrics. So we'll start at the beginning. Now, if you want to graph this in your calculators, make sure you go to parametric mode. So you go to mode, hit PAR, and while you're at it, probably make sure your calculator's in radians. But what our calculators are really good for is graphing these and giving us a table of values. Okay, our calculators are great for that. So the first thing we're going to do is actually write out a table of values. So I'm going to pick values of t to give me values of x and y and make a table. Okay, so I'm going to pick values of t. Now something I noticed right here is that I am bound. Okay, so my square root cannot have a negative under it, meaning the smallest value of t I can pick is 1. Okay, so if I pick 1 and I plug 1 into my x equation, I get 0. If I plug 1 into my y equation, I get 3. Right? I'll just keep going up. So 2. If I plug 2 in, the square root of 1 is 1. 2 plus 2 is 4. Okay, now I'm going to pick a value of t that gives me a pretty answer. So I'm going to pick 5. If I pick 5, 5 minus 1 is 4. The square root of 4 is 2. So I get 2 here. 5 plus 2 is 7. We could also pick I don't know, 10, for instance. And if I plug 10 in, 10 minus 1 is 9. Square root of 9 is 3. And 10 plus 2 is 12. Okay, so you can kind of pick some of these values of t that will give you nicer numbers. If I wanted to graph this, I'm not really paying attention to the t right at the moment. Okay, I'm just going to start by plotting my points just like I normally would. So 0, 3, 1, 4, 2, 7, and then 3, 12 is going to be way up there. And I'm going to graph this. Okay, now the big difference is that my direction actually matters with parametric equations. So I look at the order in which my coordinates go. Okay, so I start with the lowest t value at 0, and then the highest t value is at 5, and that corresponds to a point of 2, 7. So I start here, I end here, which means I'm going to the right. I'm going in this direction. I'm going up. So I'm going to add some additional arrows just to indicate direction. I started here, and I'm ending. Well, I'm not ending anywhere really, I'm just going up. Okay, so I got half a parabola there. Okay, second thing I want to do is eliminate the parameter. So what I need to do is solve for t in some capacity. Now it doesn't matter which way you do it. You could solve for y or x. I could do it for both. So if I wanted to solve for x first, use my x equation to solve for t. I'm going to square both sides, so I get t minus 1 equals x squared. So t equals x squared plus 1. And now I'm going to substitute. So y equals x squared plus 1 plus 2. And I just got that straight from the equations that they gave me, which means that y equals x squared plus 3. Okay, and that makes sense. Okay, this is a parabola shifted up 3. I only have the right side of it, but that makes a lot of sense. Okay, alternatively, if you wanted to solve for y first, then you could do y minus 2 equals t. So all I did was I subtracted 2 from both sides to solve for t. That gives me x equals the square root of y minus 2 minus 1, which means x equals the square root of y minus 3. Okay, and if you were to solve for y, you would get the exact same thing. You square both sides, add 3, you end up getting the same thing. Okay, so it does not matter which equation you use to solve for t. Okay, let's move on. Okay, this time we have bounds given to us, right? So that's going to restrict the values of t that we can use. Right, so I'm going to plug in values of t between -2 and 3, and I'm just going to use the integers. So it's going to count up, right? And if you plug these numbers into the respective equations, you end up with this table of values. Right, and for y, okay, now we can use this to graph again. So I'm starting at 1, -4, okay, and then my next point's -2, -2, -3, 0, -2, 2, 1, 4. So hopefully you can kind of see the pattern here. Okay, I have a sideways parabola. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have a sideways parabola. I started here. I'm going through. and I'm going first to the left and then to the right. Okay, one more time, we can eliminate the parameter. So probably it'll be easier to use my y equation first. So t equals y over 2. So now I'm going to substitute. So x equals y over 2 squared minus 3. All right, so I have eliminated t from my equation, which is what I wanted. All right, and one more. All right, this time I have trig values, and so I'm going to pick values of t that are very easy to solve in sine and cosine, namely 0, pi over 2, pi, and 3 pi over 2. Okay, and then it cycles again. So if you use these values, you end up with 5, 3, 1, 3, negative 1, 2, negative 1, negative 4. All right, so if we were to plot these points right now, so 1, 2, 3, 4, 5, 1, 1, 2, 3, 1, 2, 1, negative 1, and then 3, negative 4. Right, I see that I have, well, it looks like a diamond here, but if you were to plot some other points, you'd end up getting points a little bit out here. And so I see that I actually have an ellipse. Okay, and it looks like I'm going counterclockwise because I start at 5, 1, my next point is 3, 2. Okay, so I'm going counterclockwise. Okay, now if you were unaware of the fact that this is an ellipse, if you're uncomfortable with that, what we could do instead is, again, eliminate the parameter. However, we're gonna use a little trick. Okay, so if we go back to pre-cal, if there was one identity that you were gonna remember, it was gonna be the Pythagorean identity. Okay, this is the big one. This is one we use all the time. Now, what I can do is use this by taking my x and y equations and solving for cosine and sine respectively. Okay, so I notice x just has cosine, y just has sine. So I'm going to solve for cosine in terms of x, which is x minus 3 squared. I'm going to solve for I'm going to solve for sine in terms of y, which is going to be y plus 1 over 3. And now if I take these and sub them in, okay, I end up with x minus 3 over 2 squared plus y plus 1 over 3 squared equals 1. Okay, this looks a lot like the standard form of an ellipse. I'll do a little bit of simplification. Right, and from pre-cal, this is the standard form of an ellipse, where my center is 3, negative 1. 2, 3, negative 1. So that's my center. Okay, in the x direction, because it's a number under x, I go 2 to the left and 2 to the right. So 1, 2, 1, 2. In the y direction, I go 3 up and 3 down. 1, 2, 3, 1, 2, 3, and I end up with the exact same ellipse that I had a second ago, except drawn much more poorly. All right, that's pretty horrible. All right, that's it for this. See you later.